This video will be about Introduction to R. Before we get started, I would like to explain that R is a free software environment for statistical computing and graphics, and RStudio is an integrated development environment for R. So what this means is that R is the statistical program that we're going to be using, and RStudio would basically be a more user-friendly interface, or in other words, a development environment for R. So I would encourage you to go to these two websites here and download and install R and RStudio on your computer, and then we will go ahead and get started. So now once you have downloaded and installed R and RStudio, you will be able to click on the Introduction to R program in R, and then RStudio will automatically open. So this is how RStudio would look like, and this is opening up the file Introduction to R. So this is a program that is written in R and has a .r extension to it. So here is the R script window. So this is where the R scripts are going. So this is where the program is going. The console window is where the results are going to be shown. For you, this is most likely right here on the bottom. I moved my window to the side to be able to, for you to more easily see the output as we're going through these programs. So I have rearranged my windows a little bit from yours. So the first thing to notice here is that some of the lines here have the number sign in front of them, which made the lines green. So this means that these are comments, and as we are running the program, they're going to be ignored by R. So as we are starting, we need to first get the data set. So we're going to be using today a wage1.csv file. So the CSV file is the extension that of the file that we're going to be reading in. Now I have downloaded this data and I have put it into this particular location here on my computer, that is on my C drive and in the folder econometrics/data R. So that's where I have put my data file. Now you may be reading this data from the internet. In this case, you don't have to make any changes, or you need to change this directory to where you put that file wage1.csv on your computer before you run the program. So once you have put this data file into a particular directory and changed the directory, you can highlight this program here, and then you could just run it. And so as it's running, it's going to be installing certain packages, and it is basically running the R script. So now we basically have the whole program executed, and we will be coming back and explaining what we have done. Alternatively, you can highlight just part of the R script, like for example from here to here, and run it line by line, but that would take too much time. So I choose to run the whole program at once. So today what we're going to be talking about is how to set up the data, how to explore the data, how to edit data, how to export regression output, um, and how to export regression output. So here we would be starting by clearing the workspace. So how we do this is by using remove list equals ls and then parentheses here. That would basically clear the workspace that we have. So if there's any data or variables in stored in the workspace, it's going to clear it. So R uses a lot of packages, and so we could be downloading the packages and using them in our R scripts. So if we already have the packages installed, we could just update them by using update.packages. So if I remove the comment in front of this, I can just update my packages here. But since you're running this program for the first time, you would probably need to install them, and that's why we went ahead and installed them. So to install packages, we're going to use install.packages. Here we're going to be installing the package tidyverse, uh, migrator, and stargazer, and we're going to be using them later on in the R script. So once we have installed these packages, we are going to have to load them in order for us to be able to use them. So we are going to use library, tidyverse, and so on. So this is what loads the packages so that we're able to use them. I already talked about how to set the directory here. This is going to basically save us time if we have to call multiple files throughout the program. We don't have this case here, but we may in later on. So here again, this is the address on my computer where the data file is, and I'm assigning this to a directory. So I'm giving this the name directory, and this is basically the address where the data file is. And so as I'm running these line by line, one thing you can see is that they're actually echoed here in the console packages. So the console packages is showing you what is being done, and if there are any errors, it's going to show up here. So as you're downloading the packages, here as you're loading the packages and attaching them to use them, it's just is giving you certain messages. So here when I'm assigning the address into a directory, we have this line executed here. So the next thing to do is to get and set a working directory if we want to see, say for example, what our working directory is and where our files are going to end up later on, the files that we produce with this R script. So here we can use get working directory to see the current direction on the directory on my computer that is being used by as working directory. And so for me, this is a C/econometrics/program R. That's where I put this program here, the R script. Now you could set the work directory by using set working directory and give it a different name. And now if you generate any files from this R script, they're going to be going now to this new directory. So if you would like to do this, you would need to remove this number sign here to that makes it a comment, and basically just run this line to set a new working directory. Um, so next thing that we're going to be doing is reading in the data set. So our data set is wage1.csv here. This is my data file. And how we're going to read it, we're going to use read.csv. And I need to point out to the full path of where this file is. And so once I read this file, I will assign this file into something that I call data. And this is going to be the data frame. So basically our data is going to be stored here. And we can later on, when we call data, we can basically use this data as part of the R script. So instead of using the full address name, in case we're reading in multiple files, I can actually use a shortcut by using paste 0 and then the directories which I set it up above here. You see this is the address that I assigned into the directory. And so here's the file name. So instead of just repeating it everywhere throughout the program where I stored the data file, I can just always use this line, and it's going to paste this address in front of this data file. So again, this is used if we have to read multiple data files throughout our R script. So we only change the address once, and then the rest of the R script is going to work. Okay, so next, let's go ahead and explore the data that we have. So here's how we're going to be exploring the data. So we're going to be using structure of the data. So data is what we named our data frame here. So that because we named it that way, that's going to show us the data structure. So here, let's look in the data frame. So we have 526 observations. We have 24 variables. And here it's showing all of the variable names in this data frame. So here we have wage variable, education variable, experience variable, and so on. And then we have numeric or integer as far as the format of the variable. And these are the first few observations of each of these variables that we have in here. So this is, again, describing the structure of all of the data. Now, instead of looking at all of the variables, including the ones that we're not going to be using, we could just look at certain variables from this data frame. And so now let's use data. This symbol here is called a pipe. So the pipe function is a function that passes an object on the left-hand side here as the to the function on the right-hand side as the first argument here. So this expression that we have here would be equivalent to select data, comma, and then list all of the independent the variable names in here. So this would be the same as select and then data, comma, wage, education, experience. And so now that from the data we're selecting these three variables, we want to see what the structure of the data is for these three variables. And so now once we run this line, this is the result that we're going to see. So now we have only the three variables that we selected, and we see the same information, but we don't have to look into into the information of all the other the variables in the data set that we do not need. So we're going to be using this a lot later on by just selecting particular variables and then only looking at the structure of the data for them. So next thing, let's list the data and just list the first 10 observations if we want to see that. So for this, we're going to select to use the data frame. This is the pipe operator. We're going to select these three variables and then the pipe operator again. And here head 10 is going to show you the first 10 observations of the data. So here what we see is the first 10 observations. So this line that I just showed you there in the R script would show you wage, education, and experience. And these are the first few observations of the data. So for the first person, that person had $3.10 as a wage. Education was 11 years and experience was 2 years. For the second person in the data, we have wage $3.24, education 12 years, and experience 22 years, and so forth. So again, we have 526 observations or people in the data, and we selected these three variables for them to see the first 10 observations for them. Next, let's look at some summary statistics. So for this, we are going to be using the Stargazer. And so we're going to be using, so here you see more information on the Stargazer and all of the options that you can put in it. So we're going to be using a very simple notation so far. So data, from the data, we can we can summarize the data using Stargazer type equals text. And what this is doing here is going to give us summary statistics for all the variables in the data set. So here we have the variable name, number of observations, mean, standard deviation, the 25th percentile, 75th percentile, and max. So it's always useful to first look in the data and see how it looks before we actually get to work with it and run some models. Okay, so instead of looking at all of the variables like we had with the structure here, so let's just also select just 3 variables and use the Stargazer on them. So how we do that is from the data frame, we're going to select the 3 variables: wage, education, experience, and we're going to pass it on the Stargazer to summarize the data. And so now what we see is exactly the same thing as above, only that now we have only these 3 variables that we selected, and so it's a lot more concise way to see uh, this summary table only for the variables that we care about. Okay, so next, let's look at summary statistics by group. So here, from the data, let's select the variable female. Female would be a 0, 1 indicator variable. So it's going to be equal to 1 if it's female, 0 if it's male. And let's put this in a table. So what this is doing, because the variable female is 0 for males, 1 for females, we're going to see the number of observations for males and for females. So in the data set, we have 274 males and 252 females in this data set. Okay, so next, we're going to be getting some summary statistics for female equals 1. So basically, we want to get summary statistics, but only for females. So how we're going to do this is we're going to um, read the data frame. So filter female equals 1. So notice that that's actually a double equal sign. So we're going to filter, in other words, we're going to be basically keeping only the observations for which female equals 1, and then we're going to be passing it on to the Stargazer to summarize. And so here is what this line here is accomplishing. So note that here it's not the 526 observations that we had before, but only 252. Only for the female that we have here, for the 252 females in the data, we're summarizing these variables. So this one here, $4.58, is the average wage for females. Okay, so now if we want to do it for males, how we can do it is, of course, if we copy the same line, put here female equals to 0, and that's going to give us the same table for males. So we can do it like that, or we can do it in a little bit more complex but more elegant way by using this line here. So what we want to do here is split. This is going to divide our data frame. So this is the data frame that we call data. It's split is going to divide the data frame based on a factor variable. So here we have from the data $ female. Basically from the data that we have, select the female variable in here, and then we're going to pass it on to walk. And walk basically applies the Stargazer function here to each of the 2 data frames. So we have a data frame for females and a data frame for males now, and we're going to be using Stargazer for each of them. And so basically here for each data frame for males and females, we're going to be getting these summary statistics. So notice what happened with this line of command here. Now we have, this is the data for uh, so this is the data, let's see, for whom. Since we have 252 for females and 200 and 74 for males. Now, the first one is actually going to be the data for males, like this one, and then this would be the data for females here. So here, these are all the zeros for males and all the ones for females. So the average wage for males is $7.09. The average wage for females is $4.59, and so on. So this is again data summary statistics for males and for females here. Okay, so next let's talk about editing the data. So how we can edit the data, we can keep and drop different variables. So here we can um, basically select, and we can select these variables from the data frame and then assign them back to the data. So this symbol here is a variant of the pipe function above that assigns the result of the code to the left-hand side object. So here, anything that we do here, if we're selecting these variables, we're assigning them back to the data frame. So then we can call them back again if we need them in the future. So, in an alternative way, this basically we can keep certain variables this way, or this is an equivalent to dropping a variable. So if we just want to drop one variable, we can use like the minus sign tenure. And if we're selecting, if we're using select, then what that means is that we're going to be dropping tenure from the data frame here. So next time we look at the data, tenure is not going to be there. The final thing that we can do here is we can filter, and here wage less than 2. So basically anything that satisfies wage less than 2, we are going to keep it in the data, and everything else we're not going to keep it in the data. So basically this expression that we had here would also be equivalent to data, and here filter the data using this condition of wage less than 2, and basically assign this back to the data frame. So we effectively are only keeping observations that have wage less than 2. Okay, so the final thing that we're going to learn here is how to generate new variables. And the way to do that is we're going to use, for example, log of wage here. That would be equal to log of wage. So basically the log function of wage would be calculating log of wage, and that's the name of the variable that we're giving it. Education to the power of 2, we can call this variable education square. You call these variables new variables, whatever you want. And here, if we sum up south and west, let's call this new variable southwest. So now that we generated these new variable using the mutate function, we can assign them back into our data frame. So now that we have logs and squares assigned back to the data frame, we can use them uh, like later on in the R script if we need that. Okay, so the final thing that I would like to cover here is how to export, how to estimate regressions and how to export this as a regression output. And so here's how to estimate a simple regression. So here we are going to be using LM for linear model. Here wage would be a dependent variable, education would be an independent variable, and comma data, this is our data frame. So here we are going to have wage regressed on a constant and education. Now, once we run this linear model, we are going to be assigning the results, and we're going to, let's say, name it linear.model.1. So let's say we can summarize the model like that. And then summary, we're going to be calling this model again to see what the summary results would be. And this is what we are going to get here. So this line here executes and runs this model quietly. So if we want to see the results, we need to put summary of the model here that we have of the results. And this is what we are going to see here. This is the output. So formula, wage, regressed on education. So here wage is the dependent variable, education is the independent variable. These are our estimates or coefficients, standard errors, t-value, and p-value, which we're going to be discussing later on. The point here is if we want to output and export these results in a table, in a nicely formatted table that we can later on use in a paper, we can use the Stargazer. Here we're going to give it exactly the name that we assigned here as the regression results. Here type would be equal to HTML and out, I'm going to call this file regression table.html. So here the Stargazer can produce either an HTML file or a Word file, and the output would be exported to the current working directory. So that's why it's important that you change it if you don't like where you currently store the R script, because that's where this file is going to go. Okay, so now once we run this code, we can actually open the file, and I'm going to go ahead and open the file. And this is basically how this looks for me. So it's a much nicely formatted regression output here. Okay, so we can now also estimate a multiple regression model. And for this, we're going to be using linear model, wage being dependent variable, education and experience independent variable, common data would be the data set. We're going to call this linear dot model dot two. You can give it whatever name you want, and then we're going to summarize it. And this is here what we see. So this is now going to be our coefficients or estimates, standard errors, t-value, and the p-value, which we're going to be discussing later on. And if we want to export results in a table, we again can use Stargazer. So instead of just exporting the results for one model here, we can actually append the second model as well, type HTML, and instead of exporting this out as an HTML file, this time let's export it as a Word file. So I'm going to use .doc for a Word file here. And so you can export both of these model results from both of these model as a Word file. And so when I run this part of the code and I open up Word, this is the regression output that I see here. And so this is the results from the first model, and this is the results from the second model that we saw. So if you notice, these are the coefficients here, and these are the standard errors. And also the coefficient for the constant and the standard error. So if you look out at this regression output here, these are the coefficients that are being exported, and these are the standard errors that are now being put in parentheses underneath each coefficient. So they look a little bit different because we economists prefer to have nicely formatted out tables like in research papers, and this is why we're using these uh, these export functions here. So this is a very quick introduction to R. We would be using a lot of what we've seen here today later on for future R scripts. Thank you very much for watching.